again, because of wow, that's so cool. It's so synergistic the way it all works together.
Exactly. Program execution follows program text, right? It's like once this passes out of scope, we don't need these loops anymore, so they're shut down. It really changes the way you think about stuff, and it really just clears a bunch of the noise off of the table and lets you focus on the algorithm.
Wow. Concurrency and parallelism, especially with async code, is a bit of a dark art to a lot of developers, but it doesn't need to be. That's the olive branch that this library extends. It gives you some super powerful core primitives to be able to handle synchronous and asynchronous code identically using a concept called delimited continuations. In fact, it's so powerful that it only exposes like 5 functions. The rest of it is just plain JavaScript. But it's JavaScript you probably haven't seen before, so it uses that yield star syntax. There's a lot of use of generators and async generators and stuff like that. So if that's scary to you, just hang on. Midway through, Charles shows from their docs, he calls it a Rosetta Stone, and it's a way to think about translating this very advanced JavaScript syntax, and again, it is just plain JavaScript, back into something that you might be more familiar with, like synchronous code and maybe some light promise work. So it is a very technical conversation, but hopefully it's worthwhile. We hope you enjoy it. Please let us know what your thoughts are below. We got another episode of Michigan TypeScript Showcases here, and today we're looking at Effection. With us, we have Eric and Charles. Eric, I'll ask you to introduce yourself first, and we'll go to Charles.
Hi, my name's Eric Bauer. I'm a software engineer working at Aptable. I live in Ann Arbor, Michigan, and yeah, I love researching new libraries and experimenting with new concepts and programming paradigms. So I'm excited about this talk.
For those who don't know, Eric has a video on Michigan TypeScript called, what was it? Delimited Continuations. It's a real mind melter. Yeah, I had to really take a deep breath after that talk. It's some pretty cool stuff. All right, Charles.
Hi, my name is Charles Lowell. I'm a founder and CTO at Frontside Software. I actually, believe it or not, Michigan is my alma mater, and I lived in Ann Arbor for about 6 years of my life.
Oh,
yep.
Wow. Okay. Where are you now?
I'm in Austin, Texas.
Oh, awesome. Yeah, good barbecue.
So I got much love for the Michigan. Yep.
Awesome.
Fantastic barbecue.
So today, Charles, you're here to tell us about Effection.
Mm-hmm.
So what is Effection? Can you give us like a brief overview of the whole shindig?
Okay, well, Effection is, I guess, my love song to the JavaScript community on the one hand, but it's a structured concurrency library for JavaScript. And by structured concurrency, it's a little bit of an amorphous term. I don't know if people are familiar with it, but it's an idea that's gaining traction in a lot of different communities. It's certainly very prevalent in Java, in Swift. There's implementations in Go. There's a lot of different places where you're going to encounter it. And it's the idea that the lexical structure of your program determines how concurrent processes are set up and torn down. And there's a lot to unpack there, which I guess is what this talk is about.
You can look at the code, and by looking at the code, you can understand what's happening more easily?
Yes.
Even though it's async?
So it actually, the term structured concurrency actually comes from structured programming, which was a term coined by Edsger Dijkstra, who was a big name in the 60s, 70s. Lots of people have heard of it. He's the one, kind of the father of if statements and while statements. And everybody used to program with gotos and assembly language. And he was, I believe, the first person who expressed the sentiment that you should never have goto, not even once, because it destroys abstraction. And so he introduced this idea of structured programming. And the principle of structured programming is that, in a sentence, program execution follows program text. So if I see that flow control enters an if loop, an if statement, I can know that the execution is going to be such that flow control is going to exit that same if loop. If I call a function, the only place that flow control can go is back to the return point of that function, and so on and so forth. So it's a play on that, and it's the idea that you can use the same structure of your program text to understand parallel process. So Effection is this idea brought to JavaScript, otherwise known as weird generator bullshit.
but yeah, exactly. So like, but in JavaScript is always single threaded all the time. Is that true?
Mm-hmm. That is true.
So is this using like workers or something? Like how do you, what is it? So is it
I mean,
concurrent but not parallel? Is that the thing?
yes. I still don't
Okay.
really I've been working with highly concurrent parallel systems for, 30 years. I don't really understand the difference between concurrent and parallel. I mean, I think I do, but it's a little bit arbitrary. But, it works with the same mechanism that promises do, because async functions are, at the end of the day, continuations that are operating in a single threaded loop. It's just that the continuations are a little bit more explicit in Effection. Um, if that makes sense. So it doesn't use workers, although workers can be used. It's just you have code that needs to be run at a certain amount of time to continue a computation. And when it becomes its time to run, then it runs. And that's similar to the idea of async functions and async iterators. Although we can get, it's a whole rabbit hole. But the reason you need Effection and not those abstractions is the current async abstractions in JavaScript fall short of what's necessary to implement the guarantees of structured concurrency.
What guarantees are you referring to in this case for structured
So,
concurrency?
so flowing from I'll try and keep it as fundamental as possible, as simple as possible. The way I like to think of it is that no operation survives its parent. In other words, if we think of like a variable on a stack in a function, when I say, let x equals 1, I understand that binding of that variable to that value is only in scope during the course of that function. Once the function exits, I can't reference x anymore. X is no longer bound. And in fact, the JavaScript interpreter is going to release that and make it eligible for garbage collection. And the memory that was associated with that thing is no longer going to be accessible. Those are the guarantees that actually weren't in place, 50 years ago in the bad old days when, people were doing programming. So the guarantees of structured concurrency is that if a function or an operation passes out of scope, then all of the concurrent processes that function started also pass out of scope and are automatically destroyed without the user having to take any type of thing. Like we don't have to say, like in C, call free on a thing of memory. In these days in JavaScript, just the fact that you are no longer in a scope that references a variable means that it becomes unbound and can be destroyed. Boy, that was a long answer for simple. Does that make sense?
So is it like if I have a process that has many sub processes, it should like kind of trickle down and kill, like if I have a user creation event that also sends a welcome email and maybe sets up a cron job or some kind of thing to later send another reminder email, if that user is deleted, then all that stuff goes away too. Is that kind of the idea?
Yes. That's cool. The idea, right? It's scope, lifetime, and cascading destruction, just applied to concurrent processes.
Cascading downstream as well as upstream, right? So if a child task raises an exception, what happens?
Right. Yeah. Well, that's part of the thing is if it doesn't matter how you exit an operation. So in JavaScript, you can exit an operation by returning, or you can exit it because an exception was triggered. And this is actually something where there are a lot of bugs today, is if an exception is triggered, your parent can shut down, it errors out, but then all of the children, you have to remember, also need to be shut down because ultimately that operation passed out of scope. It is over, and so everything that it owned should also be over.
Common problem.
Yeah, it's a very common problem, and so that's the other guarantee. Although I do think it's part of it's a subtlety and an often missed nuance, but it is part of the same fundamental principle that no operation outlives its parent, regardless of how that parent resolves.
Yeah, I mean, Node created an unhandled promise rejection specifically because not all promises were being caught. And then,
Right.
if you're, 20 promises deep and you have an unhandled promise rejection, like how do you even begin to debug that without some notification?
Right.
Yeah.
Right.
Totally.
And it stems from the fundamental problem that you can't, there's no guarantee, there's no understanding of provenance for a promise. Whereas in Effection, every single operation, unless it is the root operation, you know exactly what its parent is. So it's arranged in a very tight tree. And, we're able to use that tree to make sure that if a parent does pass out of scope, whether it's because it returned or because it errored, we know all of its children.
Cool. I mean, let's see. I'm very anxious to see the code. Can you show us
Okay.
how?
Yeah.
Yeah.
So we'll start small. So I'm going to start with possibly the simplest Effection program that you can. So we're going to import main from Effection. Okay. And let's see, we're going to pass a generator function to our main, and what we're going to do is we are going to suspend. Okay. Now, I said this is the fundamental operation of asynchrony in Effection. And so what this is going to do is it's going to start a main, or it's just going to start a new Effection program, and it's going to just stop it immediately. But there's something. It's let's go ahead and put some output here so we can see this function operating. So if we run this now in the console, and I'm using Deno here, and I'll give a quick plug for Deno because Deno really made me love TypeScript again. I was kind of on the fence, but Deno makes working with TypeScript so fun and so easy. Like now I am never back.
Because you could just execute TypeScript, right?
Yes. It's like TS Node, except awesome. Not that there's anything wrong with TS Node. I used it all the time back in the day, but it just makes the difference go away. Like you're mixing JavaScript and TypeScript and ES6 modules and common JS modules. They really have they've sanded down all the interfaces so that everything fits together very seamlessly. So I'm assuming since this is a TypeScript group, everybody's all down with that. So recommend Deno to your friends who are maybe like TypeScript curious, or who are like, I don't like having a TS config and it's always a pain to blah, 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 blah. Be like, Deno solves all that problems. It's just like JavaScript, except better. Okay. End of plug. So let's run this script. And hey, it looks like since I put this together, a new version of Deno came out. So you can see it prints hello, and then it suspends. There's no secret there. But what happens when we can hit Control C here? Because in Effection, every operation, and I'm going to use operation and function interchangeably a little bit here. Every operation runs to completion, but that has a different meaning depending on how you complete. Because when you suspend, it means that the operation is finished, and it's not going to execute any further instructions. So if we hit Control C, you can see it actually does not print goodbye. However, if we wrap this in a finally block, and we start the program again, if I run now and I have that in the finally block, you can see it prints goodbye. And so this is something that's fundamental to Effection, and it's something that's very different. And I would say almost you could argue that it is the thing that is different between Effection operations and asynchronous functions, is that Effection operations always return. Always. So what's happening is when I hit Control C, this function returns. And every function that it calls returns, and every function that they call returns. And so this is where you start to see the guarantees of structural concurrency in action and how it's just vastly different from the status quo in JavaScript is that when I invoke an operation, I know that the child and all of its transitive dependencies are going to return, guaranteed, no matter what.
I think I'm
So
sort
maybe
of
we should
getting
stop
it.
there. That's the
Yeah. What? Tell us. Okay, so high level view, we have a top level await, which is a promise. So main returns a promise, I presume.
Main returns a promise. It actually returns a
Yeah.
task. Oh, it returns a promise. Sorry, it returns a promise.
Okay.
Because
So
it's an entry point to Effection. It's kind of your starting off point.
and that promise is never fulfilled until the program finishes.
Yes, that's correct.
And that's the way that you get this, like, we can guarantee that everything will work all the time because it's all contained within one promise at the root. Okay.
That's right. So there's one promise, which is going to contain a single root operation, which is the operation defined by the scope.
All right. What is yield star? Can you remind me?
So
I know yield.
Yield star takes an iterable and it instantiates its iterator and it runs it to completion. So what this is saying, the way that Effection works underneath the covers is that it's actually you can almost think of it as like a little interpreter that's embedded inside JavaScript, and it's issuing instructions. There's actually only about 3 instructions in Effection. There's suspend is actually an instruction. I think there's spawn and there's resource, and there's action. So there's only like 4 or 5 instructions. But every single operation in Effection is a composition of these instructions. And so the generator function is essentially a composition of instructions. And then the last instruction, the last thunk of the generator is going to give you your return value. And so what you're saying with yield star is that I want to run it and I want to get the return value.
But in suspend's case, there is no return value.
Yes, the type of suspend, if we look at it, it's operation void.
Mm-hmm. Yeah, could we look at the code of suspend?
Sure.
Yeah, let's do it.
Okay. So basically, now this is where we're getting into the delimited continuations. So what actually Eric showed at that Michigan TS meetup was the system on which Effection is built. And so Effection is built using delimited continuations. And this is something that's new about version 3 as opposed to versions 1 and 2. There are no callbacks in Effection. None. There are 0 callbacks. There are only continuations. And I think that's also a profound difference in the way we think about and reason about the code is rather than calling back and executing some arbitrary function that only has a lexical scope, we invoke continuations. And what that means is you have some computation that's paused, and then we're continuing to the next thunk of it. And it's a very subtle difference because the outside, it looks like you're just calling a function. You're invoking a callback. But the difference is that function isn't just any old function. It's a function that actually resumes a computation. And so there is a very subtle but distinct difference between a callback and a continuation. And in Effection, there are 0 callbacks.
Wow.
So when you do anything, you are just continuing you are continuing a paused computation.
So then,
in fact, we can
mechanism...
look at yeah.
Oh, God, sorry. I think we have a little delay. It doesn't matter. So I was just going to ask, that's the mechanism by which you can treat synchronous and asynchronous code the same, right?
Yes. Right. Because we're not calling back and we don't have to order callbacks, we're just resuming computations. And so the order of computations is very clear and unambiguous. First you do this, then you do this, then you do this. And so at any point, all we're doing is we're jumping back into a computation, but because we know where we are, because it's implicit in the continuation, we don't have to have any code. There's no locks, no mutexes, nothing like that.
I have to ask, with this code in front of us on your cursor, it looks a bit like Rust to me with the result and okay. Is this in any way inspired by Rust, or have you done any Rust that kind of informs your choices on this library?
Yes, I've done some Rust. We actually wrote, my first Rust was working with a an Effection v2 library to shut down Windows processes by sending them a Control C. And so it's a little bit of Rust code. It is definitely inspired by Rust and by Haskell. I've done a little bit of that. And so there, in Haskell, you represent failure conditions with these result objects. And so I find that when you're working with errors at a abstract level, and you're working with computations at an abstract level, being able to represent the outcome as a value is extremely helpful, because you're basically routing signals around, and you're saying this succeeded and this failed, and if this then that, and so it fits very naturally. I'm still kind of on the fence. I know there's a lot of backlash against exceptions and error handling. I still kind of like it for userland code and being able to concentrate error handling at the top of your stack, because essentially it's like a supervisor. And actually, exceptions are another form of delimited continuation, except they're restricted to the domain of error handling. So in other words, when you have a try-catch block, you're essentially capturing a continuation at the top of your stack, and then you're executing a bunch of code, and then you say, well, I'm going to continue up at this point. And in fact, you can use delimited continuations to implement try-catch. So we use delimited continuations here to implement structured concurrency, but you can use them to implement if statements, while loops, try-catches. They're really a fundamental flow control abstraction. And you can use them to any flow control that you're familiar with, you can pretty much do with delimited continuations, which is one of the reasons I'm so happy to have found them.
Yeah, I can relate to that. I was just going to say one little quick stupid thing. One of my first jobs was working with VB6, the Visual Basic 6, the one before .NET existed. And I worked with a bunch of COBOL programmers as well. They sat next to me in the same row. And so we were translating COBOL to VB6 some days. The only way to do exception handling in VB6 was with gotos. You make a goto that's below the return of the function. And so it's not accessible code otherwise. And then if you have to jump to that, you would go to that label somewhere else in your code. And that's all there is available to you. There's no exception system. And when people complain, like you were saying, about exceptions being nasty in some way, and that Rust does it better. I love the way Rust does it, but TypeScript has some stuff coming down the pipe for being able to give a type for what a function will throw. And there's some things that I think could happen in the future to make exception handling in TypeScript even better. So I don't know. I'm hopeful that over time people will start to see that there is like a happy middle ground, I think, where we can have exceptions and we don't have to do like in Go. I wrote Go for some, was the Kubernetes thing behind me. I wrote Go for some years, and it's very literal in Go. There's no exceptions. You have to do everything with values and multiple returns.
Right.
But anyway.
And I really like working with results like with Rust in certain domains, and especially when you're writing code that's about code. But when you're writing the code, it's nice to just not have to worry about error handling and make sure that the system is going to handle it for you. Because it's almost like in Go and in Rust, although there's helpers for it, it's like you have an implicit catch block, one way to think about it, around everything. And so if you drop it on the floor, you dropped it on the floor. Whereas with exceptions, you're kind of forced into dealing with them. And you can also trust. I mean, So it's an interesting balancing act that you have to do. One thing I wish that they had in TypeScript is being able to have overloaded exception handlers. So there's very few things that I miss from Java in my days doing Java. But one of the things that was nice is they basically had polymorphic catch blocks, where you could just very easily let certain classes of exceptions through and deal with certain other ones. Because whenever you're doing some operations, if it's something that's, the file isn't just there, that's one thing that maybe you can't deal with, but if the data is in a bad format, but the file's there, then you can. And so being able to say, I want these exceptions to go through, these I want to deal in rethrow, and these one I'm just going to straight up catch is very nice in 3 separate catch blocks. Anyway.
Yeah, Ruby has like the ability to rescue specific error types and things like that, which is useful.
What would you say is the main use case for Effection? Like, is this kind of recovery? I envision like I'm on a travel website and we need to book someone a hotel and a car and a plane flight and all this stuff, and I want to be able to undo it if one of the things goes wrong. I want to be able to cancel the others. I mean, I'm just guessing, but
I would say the primary use case. I think the main use case is anytime you have asynchronous code. Like I don't really not use Effection in any JavaScript project that I do now, because the thing is it's about providing guarantees for your execution of your program. So it's, for me, it's almost like, it gets rid of the go-tos, so to speak. So because like JavaScript doesn't have go-to for flow control, but it does have go-to for asynchrony. And so it's kind of like asking the question, when would you use if statements and while statements as opposed to go-to statements? And I would kind of say always. So now in particular, we use it for server processes. Eric uses it on the front end. It really, anytime you've got several things executing, or you want certain things to stop while other things continue, it just makes it so much more easy to reason about. So, maybe this would be a good intro into like expanding the example that I was talking about and kind of showing that. So we'll back way up. So here we are with our suspend function. And so one of the things that I thought would make a good example was to just embed an express server here inside our Effection block. So let's go ahead and import express, or sorry, was it? Okay, and what we'll do here is we'll say create a new Express app. Let's go ahead and give it something. We'll say response. Okay.
Classic.
What's that? Classic.
Yeah.
And then we want, and then we actually don't want to continue. Let's go ahead and say let server equal app dot listen. And in fact, let's go ahead and do this, and then finally we'll say server dot close. Okay, I think I got that right. Oops, it didn't I've got a syntax error here.
Oh, yep.
Okay, better? Okay, let's give that a shot. Oh, and then let's go ahead and
I guess we have to call it.
We have to call it. Well, let's so we actually have, we're already getting into the places where Effection can help you. Although you can do a similar thing with asynchronous here is, this is something that's interesting about Node is, this server, we can't actually get the address until this thing is, the listen event happened. So what we want to do is we actually want to use an Effection action here, which I think I have it pulled up here. There's do I have my Rosetta Stone? No. If we go to the Effection docs here, there's kind of a Rosetta Stone. Let me blow this up so everyone can see it. The difference between, and I'll zoom it up.
Oh.
So a translation between async and Effection, and there really is, for anything you can do with async await, there's a direct analog in Effection. And this is actually one of the design goals, which we can get into, is really we're trying to make it as familiar to JavaScript as JavaScript programmers could possibly be. So for a promise, you can think of that as an operation. The promise constructor is like having a new action. For await, you have yield star, and these are things are substitutable for each other. So armed with this knowledge that anytime we would use a new promise constructor, we would really want to use an action. In Effection, let's go ahead and create an action. And so what we do is we only continue the operation when the server's listening. So we want to, so action takes a function that has resolve. Listen takes a callback, and what we're going to do is we're going to resolve here.
Oh, okay.
Right? And so you can see we're basically, this is how we do a callback in Effection. But remember, I said there are no callbacks in Effection. This is a continuation, and the continuation returns you right back to this point.
After the listen event occurs.
After the listen event occurs.
Okay.
And fundamentally, that's what's going on with an await statement or await an expression.
Mm-hmm.
It's just right in your hands, and the connection is very direct. And so now we can say, let's just, the app is here. All right, I think, man, this, tell you what, let's do some TypeScript.
Mm-hmm.
So we're going to say this action is going to return a server. That'll make sure that our function, our callback function, only accepts a server, and that this thing is a server. Okay. And
I see. At the bottom of your Emacs, it tells you the type. Okay.
Yeah.
I'm not.
Yeah.
I'm like, how does he know?
Sorry. Yeah. You have to. It's a little bit. I don't know, where does it show on VS Code?
Yeah, I can see it at the bottom there. It's a hover. It's like a tooltip.
Yeah.
Usually.
Yeah, I think you can get a hover too. Does it show a hover? No. Oh, okay.
Sometimes, yeah.
Sometimes. Okay, so we'll say, let's just capture the address here, because this is something that's, I think I mentioned it in Express. If the server isn't bound, then this address returns null. So we don't actually want to execute that until it's resolved.
Mm-hmm.
So we want to say address.address and then address.port. Okay, and if we've done everything correctly, I guess I don't need this type. Okay, so let's go ahead and start. Okay, and you can see it actually started the app there on line 53. Let's see. Yep. There we go. So now we're suspended there, and we do the server closed. So, and then what's nice here is that if I'm going to Control C, then everything is going to return, and so the server is going to close. And so you can see it actually executes the server. And truthfully, we should put this also in an action, because the server close could be asynchronous, and I think this takes an error back.
If there's an error?
If there's an error, yeah. Is it? What's the type of close? Okay. My types are messed up. I think it might be because this is Deno inferring a Node API, and it might be getting a little bit confused.
Yeah, all the same. I get what you're saying.
Yeah. So we probably should put this in it. Let's see if we can do that. So we can say if error, then we want to reject.
Mm-hmm.
Yep.
So this is the
And
way, like what you're showing right now is if somebody wanted to make like Effection wrapper for Express and just take these things you have on line 20 to 28 and bundle them up and
Mhm.
expose them as like a kind of I don't know, expansion pack library. This is the way they would do it, right?
Almost. I'm really glad you asked that question because that fits in perfectly with the next bit of code that I was going to demonstrate. Let's first verify that this is going to work. So we start that. Yep. And it stops, and we're guaranteed to run this asynchronous shutdown there. So the way that you would do that, this is really nice and it works, but you'll see that it's actually in line here. So how do we bundle up an Express app? How would we wrap it? And the answer is we would use an Effection resource. And what that allows us to do is we can bundle the startup code and the teardown code all at once. So what we would want to do here is we would want to use an Effection resource. Okay. And we would say, let's just say let server equals
Does it need to be
yield
defined within
resource.
main? Like, could you take this and make
No,
server?
we're gonna do it incrementally. So this is gonna be part of our refactor here. But I'm just gonna show the steps by which you would do it. And in what resources do in Effection is they're computations that provide a value to the caller of the computation. So anytime you do a resource, you actually there's an operation that it passes you, and you invoke that operation to resume your parent computation. So here, where this is a server resource, and so you can see I've got this thing. The hover on the bottom is I've got a operation that's going to provide a server. So what I'm going to do here is I'm going to take all this code. I'm going to put this up here, okay?
Wow, just like
and
that.
then at this point, oops, yep, I'm going to provide my server. And then finally, I'm going to take my teardown code, which is this thing.
Oh, okay, and then
Here.
we need reject from the action.
Where
does reject come from?
Reject is coming. Oh, did I not? Oh, I forgot. You're right. I didn't. Tell you what. Let me just try. Let me just bring that code completely up. Let me spell finally correctly. Okay. So now we've wrapped this thing in a resource. Okay. And so this should still run if we've got all of our variables defined correctly. Okay. Yeah, you can see there's our code, and then it's gonna close. But what we really want to do is just take this resource and extract it into its own thing. And let's call this, we'll call it use app. So we'll define function use app. What this thing does is it returns a resource.
Mm-hmm. And the resource has been provided the server. So that's the mechanism by which on line 9, server.address is still there because that's what we passed to provide.
Yes, we pass. You can see how use app returns an operation server, and so because the app resource provides a server, that's why server is available here. So, but what's nice about this is now this app is associated with this scope here, and so whenever this scope is exited, whether through error or through return, the server will be torn down, and we don't have to think about it. So you can see here we've got, there's our app. We can even create 2 apps if we want. Let's actually, we'll just we'll call this server 2.
Mm-hmm.
We'll make this address 2. No. Yep.
Mm-hmm.
Like that. And now when we start our application, we got 2 servers.
Wow, just like that.
And when we Control C, they both get shut down cleanly. And so we don't have to think about this. So I guess we should pause before we go on. For any other questions, I think if we go here, you can see we now have 2.
If I wanted to pass data, like let's say I wanted to parameterize the hello world part of this.
Yep.
I would just pass that as an argument to use app, right?
Right.
Because it's just a regular function. Wow.
Yep.
Mm-hmm.
So.
Yep.
That's how we would do that. And then we would say this is hello world. And this one is hello planet. And so now when we restart, that one's hello world, and that one's hello planet.
Awesome.
Okay. So should we pause there? There's one more thing that I wanted to show.
Yeah, I wanted to ask you, Charles, about the typing for Effection, because you've spent a lot of time thinking through iterables, iterators. These are all common JavaScript constructs, but we also have the you also have the concept of an operation. And I've worked with generators a lot. Getting the types correct with a generator with just a bare yield is difficult. Could you talk through like how you arrived at the yield delegate and how you were able to lock the types down? So when you call useApp, which is just a normal function, you're getting an operation that you can then yield to properly.
Right. So this was actually somewhat of an Achilles heel for Effection v2. Effection v1 was written in JavaScript. Effection v2 was written in TypeScript. However, because we used bare yield statements, it suffered from the problem that you're describing, where what was on the left-hand side was basically inscrutable, and you had to add a manual type annotation. And at the time that we wrote it, we thought that it wouldn't be a problem, but it really was something that was extremely vexing, because once you actually kind of enter the TypeScript community and you have all the tools at your disposal and you have your language server that's constantly telling you the type of everything, it's really hard to live without. And so we ended up in this situation where as a shop, we were doing a lot of TypeScript and we were leaning really hard on the TypeScript, but basically everything on the left-hand side of an operation was untyped. So we were really looking really hard for any solution that could address this. And so at the same time in Effection v2, the type of an operation was extremely broad. So it was a union type that had like 6 member types. So it was really hard to know what you had at any given point and what it was going to yield on the left-hand side. And so for v3, we wanted to really think really hard about how we can narrow that down to make it as easy as possible, so you can just think about the data that you're working with in these operations and the shape of that data, and not have to think about the operations themselves. So in v3, there really is one operation type, and that's it. And all it is it's an iterable of instructions. But the good news is you don't have to care about the shape of the individual instructions. You only have to worry about the return value. In other words, the last instruction that ever executes as part of an operation is going to return you something. And so that's all you have to think about. And so as a happy coincidence, or not really as a happy coincidence, but just as the way that generators work in TypeScript, TypeScript is really good about reasoning about return values, and not about the individual values that happen as part of your computation. Because when you're inside a computation, you can see we got a lot of values. We have a server, we have two servers, we have a void. So the kind of intermediate stitching values for this computation, there's three of them, and it's like server or so it's server or void. You can't really work with that type. But if you're only attuned to the return values, which is what you get with yield star, then the typing just works out seamlessly, and it's every bit as good as if you were working with native async await code.
This makes me wonder. I wanted to ask you about testing, but maybe we can segue to testing by asking you about type testing. So it sounds like the types of your library are really important to you, and they are a huge portion of the value you deliver to your users. How do you test to make sure that the types don't break? Not the runtime code, but just the type stuff.
Well, so I don't think we have that much type testing. Let me just, I don't even know. Let's see if we have any.
Sorry, I didn't mean that to be such a loaded question, but anyway.
Yes, we do have some. We do have some.
Okay,
so actually so this is in the event testers. So basically this is probably the most, so basically what you do is if we have a utility for getting the events off of an object. And if that thing is an event target, we want to very closely narrow what type of event you're going to be receiving. So you can see, like, for if you've got a WebSocket and you're listening for the close event, you're going to get, a strongly typed close event. And if it's a DOM element and it's a click, you're going to get a mouse event. But if it's a key press, you're going to get a key event, and so on and so forth. And so, we want to provide as high fidelity a experience when it comes to the types as you can possibly get, and make sure that it really mirrors the experience that you're going to have if you were just doing normal JavaScript. Because at the end of the day, that's what we really want to do, is make sure that it feels like JavaScript and you're not losing anything. You're only gaining stuff by going with structured concurrency.
Awesome. Yeah. So you got TS expect in there, I see. And then using that, that's really cool. What about for regular testing? I have to say, one of the reasons I used to be a Redux geek from before Redux existed, I was into Flux and all that. And then Redux Saga came along, and I really fell in love with the docs on Redux Saga because they sell you on the concept of like going through the task of learning generators and all this by saying, hey, but what's going to happen when the day comes that you need to test this stuff? We give you a way to test this stuff. So now I push it to you. How does, could we write a test for, or even like a faux test? It doesn't have to really run, but how would somebody write a test for the server we just made or something?
Okay, let's see. So how would someone write a test for the server that you make? Okay, so testing is actually one of the places where we use Effection a lot. And the reason is because you want to do a lot of setup and a lot of teardown in between test cases. So,
or you could just show us if you have an example in mind, that would be just as good to show. Let me
see what's something. Okay, so we have the Effection tests themselves. Let's see. I think I have some tests that I was writing where I was starting up a server. Here, let's see. So I think it was in this little library that I've been working on. Let me just do this right here. I'm using Astral, which is like a playwright library for Deno. And what I'm doing here is I've written a little helpers for integrating with the BDD test library. So everything that runs in it before each gets launched in a particular scope. And we haven't really covered that yet in our demo, but a scope is a way that you can just get a reference to that explicit scope. So the things that we were talking about, and I can now launch a browser and I can actually set it so that people can use this browser. Inside, I can set a context so that people can use the browser, and then I basically enter some teardown code. And what's nice about this is then everybody can use the browser in the tests, but then I can be sure that the browser is closed down in between each test. And I don't have to worry, my tests don't have to worry about setup and teardown. And so then I start the same thing. I start a little test server.
I see. And then you don't need an after each function where the close happens because it's handled by the fact that it was started.
Right. It's handled by the fact that it was started, handled by the fact that we're using a resource. So the browser is a resource, the server is a resource, everything's a resource. And so then I don't know, the after each writes itself. So you can see then in here, I'm using a page, which then basically what I do is I use the browser, I use the server, I navigate to the browser, and I'm doing a bunch of other different stuff here. I'm basically starting an async process to iterate through all of the console log messages that are coming from the browser and all the errors that are coming from the browser.
Wow. Okay, wait. I'm sorry. My brain is still taking it in. I've never seen a yield star in this position. So there's like a yield star and then a spawn and then a for loop and a yield star and an each. So
So basically what we're doing here, spawn is something that we can get to, but you can kind of think of it like just a special resource that just executes an arbitrary function until its end. And so what we want to do here's the problem, is we're connecting to this playwright browser, and the console and the errors are logging inside the actual browser, and we want to print them to the server console, the test suite console that's creating them. And so what we do is we're spawning a process that's going to loop infinitely over all of these messages and log them to the console. But what's interesting here is, and this is something that you see a lot in Effection code that you don't see, is you use a lot of infinite loops, because the truth is that no loop is truly infinite. So what we do is we spawn this asynchronous process that's going to loop infinitely and log our console events and log our error events. But then when we pass out of scope, both of these tasks return immediately from wherever they were.
Again, because of wow, that's so cool. It's so synergistic the way it all works together.
Exactly. Program execution follows program text, right? It's like once this passes out of scope, we don't need these loops anymore, so they're shut down. It really changes the way you think about stuff, and it really just clears a bunch of the noise off of the table and lets you focus on the algorithm.
Wow. Did we talk about Signal? I'm trying to understand what messages is.
Okay, so Signal, so basically you need a way to get from a callback to a continuation. Remember how we said there are no callbacks in Effection, only continuations. But clearly you got a lot of JavaScript code out there that is the only point of it is to call a function.
Well, like add event listener.
Right, like add event listener, right? And so what we're doing here is we are essentially creating a thing of which we can create a bunch of continuations. So we're basically binding this function, which then when you're subscribed to this signal, you can basically it will create continuations for you, is one way to think about it. So you use them to, it's a way of taking a function and lifting it into Effection.
Yeah, this is a really important concept because we are living in a world that is not completely consumed by delimited continuations. We have to have a way to get things in and out of a delimited continuation. That is the key. So a signal in this case is a lot like a channel where you can send messages and listen to those messages inside of a delimited continuation.
Yeah.
Okay. Yeah, it's a what's the word I'm looking for? Yeah, I got it. It's a way of migrating things from one universe to the next so that we can move on with our
Right.
lives. And
Yeah, we can also use it more generically, though, because we can use signals inside of delimited continuations if we want to.
Right.
But the way that this is modeled is very similar to a Golang channel, where you can send messages into a channel and listen to those messages and iterate over them.
that makes me wonder, like, can you tell me any dirty secrets about, like, can you deadlock these things? Is there, like, are there weird edge cases that you regret that they exist, but they do exist kind of things? You know what I mean?
So I guess the question, I mean, I think the answer is I can tell you about edge cases and things that I wish didn't exist in V2. But V3 is still relatively new. I think we had an alpha stage. We're currently in the third beta. I expect that we're going to release version 3 before the new year. So I don't have anything that I hate about V3 yet. Doesn't mean that it's not there lurking. What's that?
I got one.
Okay.
Well, there's a couple.
Okay.
And Charles and I have gone through this a bunch of times, but those yield spawns, those return tasks.
Yep.
And if you don't await that task explicitly, like he's using it to his advantage in this case, but if you don't await or yield star the response of a spawn, and the parent passes out of scope, it shuts that task down, whether you wanted it to or not. So you have to be mindful, because you have to explicitly wait for tasks, or the parent will shut it down when it passes out of scope. So he's using it to his advantage, which is awesome. But I could see users not knowing that and getting into a situation where a child is being shut down when they didn't want it to.
Right. It can be confusing. It can be the thing is it's I would say it is counterintuitive, but only because your intuition is wrong. And I say that not as like from a judgment, but from like this is the way we kind of grew up. We were frog boiled into this idea that, like, when you run code, it's always going to run, and it's going to run until you stop it. And here it is, you're basically leveraging lexical scope to say that, like, when I'm not in this function, this thing's not running.
Yeah, it's
a little bit weird. It's definitely weird. It's something that you have to become attuned to. I wouldn't say that your intuition is wrong. It's just it's a new dynamic at play that you have to be mindful of, because everyone who works with Effection gets bitten by this, myself included. It still happens where I'm like, oh, right, that thing's not in scope anymore. It's not running, of course.
I mean, I guess I should ask. It's appropriate for me to ask. This is some pretty next level stuff, and in a workplace, it's a dream of many people to work with people who are all on board with doing this kind of work. But I'd like to ask, I'm sure you must have at some point encountered people who think this is nonsense and anything that uses generators is over engineered. And I don't know, maybe you can even fill in the blank with what kinds of complaints people make. What do you say to that? And, what would be your pitch to those people? I'm assuming you've given it before, so.
Yeah, no, I think the thing is it's a very valid, actually, sentiment, because you have to learn something new. And so I don't want to downplay the cost of doing that, especially when you have work to do. And it's going to introduce a new way of doing things, which is different than the old way. And so you're going to have a dissonance between the old way and the new way of doing things. So to that, I would say two things. One is that it's a lot easier to learn than you think. Yield star is essentially await. And at some point, await was foreign to you and felt weird. And, you were like, what is this thing? Why can't I just use promises? And why can't I just use callbacks? And it all works fine. And then you got to taste it and you're like, whoa, this actually solves a lot of the problems that I didn't even know that I had, or I did know that I had them, but I wasn't aware of it rationally, only that it was like branches hitting me in the face, but now I can see the whole tree. And once you start to program in this way, you start to recognize the pains that you don't have. you start to recognize that things are extremely, extremely simple. Once you kind of learn how to parse this use page helper, all the noise of teardown is taken away from you, all the kind of coordination that you would normally have to do, and you get to focus on what it does. This sets up a browser, connects it to a server, and it starts spooling the output of the console and the errors. And then it makes sure that the page gets closed. Okay, done. I can deal with that. That works for me. So the dividend is in the radical simplicity, because now this thing also is composable. Like, I can use this page in the same way that I can, I was able to use the browser inside the use page helper and the server. You can compose use page however you want, and you're still going to maintain the structural concurrency guarantees. So the level of stuff that you can do is much more elevated because it's simpler and because it's easier to understand. So you get both of those benefits. And then finally, the thing that I would say is that Effection itself, of all the different ways that you could approach this problem, we have tried to be very, very meticulous about keeping it as close to JavaScript as possible. Instead of using functional composition, which you can do, we wanted to make it really easy to use a for loop. I know it's like weird to parse your for let event of yield each messages, but the structure of a for loop is evident there, right? You can recognize it. And once you your eyes focus, you begin to recognize these loops immediately. And so we've really tried to minimize that cognitive dissonance that you're going to experience as you adopt this paradigm, because it is so familiar with normal JavaScript code.
Yeah, to belabor on the for loop there, this is huge, because if it was a for each, you don't have flow control inside of that for each. You can't break or continue. But we're leveraging the power of JavaScript for to give you flow control, and it's incredibly powerful in Effection.
Yeah,
it is familiar. You just have to learn.
I hate to admit it, but you're so right about that. It's a problem that I struggle with, because I always reach for each, the array method. And I love using library. I use Ramda a lot, and Ramda's solution to this is to create resolved, I think is what they call it. It's not a solution, because there is no solution, because like you said, you can't escape. You can't break out of a for each early. You just have to keep going until the end. That's how it works. Right. And this has got a huge benefit in that regard.
Yeah, Effection is all about flow control. Async flow control, and we are Charles is leveraging as much of the JavaScript constructs as possible.
We have to give credit. It was actually Eric's idea. This each.
That's why I brought it up. I was just throwing out crazy ideas, and Charles implemented it. So.
Let me see. I can send you in the chat here. I want to send you a little thing. If you could pull it up. I think this will be not very surprising code to you guys, but so I wanted to bring this example up. This is a kind of condensed version of a question that I ask in interviews a lot. And I like to ask questions. It's not relevant to this, but I like to ask questions in interviews that don't have defined answers. I mean, this one obviously has a defined answer, and I bet you guys know how this works. But I find that this is usually surprising to people, and I'm interested in knowing what happens when they encounter something that's surprising. And I mean, just to ruin it, what happens when you run this is that it logs A and B.
And B. And now this is actually another core difference between Effection. So let's talk it through. Yeah.
Yeah. I mean, the idea is really actually fairly straightforward. Promises are not lazy, quote unquote. When you create a promise is the time that the console log runs, not when you await it. But a lot of people have the expectation that, oh, I just created the promise, so it doesn't happen. And I've been in situations before where it's like someone will say, oh, that fetch hasn't been awaited yet, so the network request didn't occur. And it's like, no, bro, the network request occurred when you created the promise, which can create very real issues. I would love it, actually, if you want to refactor this into the Effection style. That would be very interesting.
Yes, let's see what happens.
So, I mean, while you're typing, it's just the reason I wanted to bring this up is because sometimes even these basic, I mean, it says I'm saying basic, but I myself didn't understand how this worked at a time. Julia Child cooked her first pot of pasta at one point, right? So I'm always interested in the way that we can go about helping our colleagues get over the hump to be able to reason about these things better, because these libraries inevitably can go nowhere unless people are willing to think it through, you know?
Right. So let's see what happens when I know what's going to happen. What do you think is going to happen when we run it in Effection?
Okay. All right, here we go. I'm in an interview now myself. Look what I did. So, all right. We have our await main. That's the top level promise, the root thing that we were talking about. Our generator inside of that is yielding an iterator. Okay.
I'll spoil it for you. It actually behaves. I'm glad you chose this example because it behaves intuitively.
Oh, interesting. Okay, so
an operation doesn't do anything unless you run it. In other words, until you yield to that operation, it does not run.
It's lazy.
It's lazy.
Oh, feel free to add this to your README.
Yeah, mechanically under the hood, we have to call .next on B for it to run.
Right.
Oh, so I was close when I was saying there's an iterator, but it hasn't been iterated yet.
Yes.
So that's why the console log never occurs.
Right. It doesn't make progress on its own. You have to. It must be part of some continuation.
Wow.
It must be the continuation of some other computation before you can run it. You have to call .next.
What I like about what's on the screen is the only thing here that's from Effection is main, and the rest of it is vanilla JavaScript.
Yeah,
that's something that, go ahead, Eric.
That was part of the question I have around like the types and how you manage to get like your yield starring A, but you didn't put a type on A.
Right. So I think you actually will get, we do need to, it's going to use the generator type if you don't actually, if you don't annotate, if I don't annotate this, it's going to use, that. So if I have A, you can see it's returning an operation, but otherwise it's going to tell you that it's a generator of instructions.
Got you.
But you were still able to run it without providing the type.
Yep.
Yes. Yeah, because if you look at the type of operation, it's just. Can you see that on my screen?
Yep.
It's just an iterable of instructions that returns a T.
Yeah, and that iterator, that symbol, that iterator part is what allows it to work in a for loop nicely as well too.
Yep.
There are so many little goodies hidden away in how TypeScript works that only people like you folks get to wrangle with. I think regular library authors don't, or like regular app authors don't have any reason to care about those things, but they are like unbelievably critical to this kind of library. I think it's very interesting.
Yeah,
I have one more
it
thing,
absolutely
Charles,
is.
that I want to ask you. We've been talking about async await. We've been talking about operations. We've been talking about delimited continuations and generator functions. And we mentioned how, because we have to work in the ecosystem of JavaScript, promises are everywhere. You're going to use a promise. In Effection, you're going to use promises. Could you just show, because with async await, you can await a promise. How do you do that in Effection?
Right. Okay. So the way that you would do it is you would use, we have a special helper. And the reason you actually have to wrap a promise in a function is that there is no way to return from a promise. once you await a promise, control is not returning to your async function until that promise settles, ever. And that's just a constraint of the runtime. And so we have to, because the guarantee of structural concurrency is that every function will return, we have to be able to protect ourselves from a promise. So to do that, we actually have a little helper called call, which also Eric was instrumental in helping us implement here. And what you can do is it takes a call, will take a promise or an async function, and it will create an operation out of that promise. So you can see here, I'm taking a promise and I'm returning an operation void. But I can return something like hello here. And you can see there it is. So it's very easy to interoperate. It's very easy to create operations out of promises, very easy to create promises or operations out of async functions, very easy to create streams out of async iterables, very easy to create subscriptions out of async iterators, because we've been very, very particular about maintaining this one-to-one mapping between vanilla JavaScript constructs and Effection constructs.
Mm-hmm. That's quite a superpower. I'm very impressed by that part of the library. That's like one of the things I'm going to take away is, there's surprisingly little library specific code to make this all. I mean, if you don't know what you're looking at, it can be very intimidating. So to you viewers who are watching this, don't be afraid. If you're afraid, just keep going.
The API surface area for Effection is like 5 functions.
It's so tiny.
It feels very familiar to React in that way. There are very few constructs you have to actually learn in order to be productive inside of the Effection world. Like for example, I need to do a fetch request, an HTTP request. How do you do that in Effection?
In Effection, you use fetch. And so what I would do here is I would say, here, let's do fetch. We can fetch the Effection website. How about that? Here, so this is a response. Let's see. Okay, so we'll fetch that, and then okay, and then if we run it, that's probably going to put a whole. Oops. Yep, there's the HTML there, and then but what we really want to do is we want to use an abort controller. Because we want to use an abort signal. So we say let signal equals, because we want to be a good citizen and we want to tear down after ourselves, and so we pass the signal to fetch. Now what's different about the experience of using this with using vanilla JavaScript is, notice we're not creating abort controller, we're actually creating an abort signal. And when we do this signal is now bound to this scope. And so what this means is when, if we control C out of here, it's going to fire the signal no matter what. So we don't have to worry about, we don't actually have to worry about the other half, which is the abort controller part of it. And we can just get the signal and we can pass it to the fetch.
Which is important because if you're making a library that does these calls, inevitably your users are going to file an issue telling you, hey, I have to have access to this abort controller, and this is the way you'd give it to them.
Right.
Yeah. That's amazing. Well, I mean, we could go on for a long time. I have some follow-up questions. Is there anything you'd like to see next? I know that you're on the cusp of V3. What do you think V4 will look like? Or do you have any, or maybe V3 is the end, like Mac OS X?
So I think, V3 is definitely going to carry us through the next year. So, when we were talking about things that I hate, I could definitely tell you a lot of things that I hate about V2, although I love V2. But for V3, I think one of the things that we want to be able to do is have a really nice inspector, because one of the unsung things, and was really nice about V2, which we actually haven't updated for V3, is there's an inspector, because you have a tree of essentially operations that you have a reference to all of them. And so you can see everything that's going. So one of the ways that I like to think about Effection and explain it to people is it's like computational components. So you can almost like think of these as React components. One of the things that's nice about React components is you don't have to tear down their children. I don't know if any of the people watching this remember like the bad old days of jQuery, but one of the most annoying things about jQuery that React came along and really solved, and really the whole component movement, is when a component is being shown, it's being shown and its children are being shown. And when that component is no longer being shown, its children are not being shown. And you don't have to worry about that. The rendering all happens for you. And so you can almost think of Effection operations as computational components. So I've got, this abort signal, and this computation that's associated with the abort signal is in scope. And then when it's not, it gets removed and taken off the scene automatically. So in the same way that React has an inspector and dev tools, because the components are arranged in this tree of parent-child relationships, the same is true here, where you have a tree of computations that are arranged in child-parent relationships. And so being able to surface those relationships, surface the operations that are happening with those things. So like, for example, logging is a big one. Being able to associate, when something goes to the log, we actually have the provenance of that log statement all the way up to the root. And so what it allows you to do is say, where is this log statement coming from? And, the ability to turn off logging for different parts of the tree. So if I've got a list of servers and I've got a couple of request handlers in here, those are going to be in the tree somewhere. And I say, I want to see the log output from these request handlers, but I don't want to be bothered with, everything else that's informational. Exactly.
Yeah, I would love to see this as an integration for GetCentry, Century.io. That would be a really cool application, because GetCentry's whole thing, for those who don't know, GetCentry's whole thing is like being able to capture this error reporting on when your app crashes, your web app crashes. And sometimes it's nice to know that, but it's also punishing because you can't figure out why or where it's breaking. But if you have something like this, you could practically replay the tape and see like where it was in execution, when it broke, and what everything is that it had built up. It's like its own little call tree you can get. Yeah, it's super cool.
It literally is its call tree, and it's very nice because it's all implemented with continuations. You can always insert a continuation between a continuation to do that fun stuff.
I had two more quick questions I wanted to ask. The first one. Administrative item. I guess they're both administrative items. So recently we have some people at Michigan TypeScript working on the idea of creating a survey. There's like the state of JavaScript survey. Well, we've been thinking it might be nice to have a state of TypeScript survey, but not for like everybody, for library authors, for people who are using TypeScript in this way. Of course, anybody is welcome to take it, but we would like to fill it with questions that are, maybe you guys have some questions about generators that you would love to know. So my question to you is, if you could put a question on the state of TypeScript survey that asked some usage question or some fact about maybe generators or something like that you'd like to know what people's familiarity is, do you have one in mind that you would ask?
Oh boy. Okay. Well, that's a hard one. So
no pressure.
If I understand, you're saying, if I could try and take the temperature on the wider community, the TypeScript community, about how a question of TypeScript as it pertains to generators or to Effection in general.
Right. When you build this stuff, is there a question you ask yourself, like, man, I wonder how many people know about XYZ or are familiar with XYZ?
So I would say, there's a couple questions that spring to mind. So one is, how much do you rely on the types to understand and learn about a library? The second thing I would want to know is, like, how do you feel like when a type, like which would you prefer? A single function that takes a huge union of types, or a lot of functions that take a single type?
Great
That
questions.
those would probably be my biggest one.
Awesome. I love
Because
it.
because that's when you're designing APIs, that's something you have to account for. And you see a lot of APIs where there's a ton of overloads, and maybe there's a ton of type unions, and that can be helpful in a bunch of different contexts. But I wonder how it affects learning and how it affects like being able to break down the types to their component parts when you are only presented with one at a time. And so, understanding that would, I think, would be very, very helpful in API design.
Awesome. I love it. We're off to a great start. And we're also starting another question series, I suppose, on this one. Somebody reached out to me and told me, it'd be nice if you asked, I guess there's a podcast called Diary of a CEO, something like that. And they ask every guest, what's a question that you would like to ask the next guest? And so it could be about anything. It could be about, shoelaces. I don't know. But do you have a question you'd like me to ask the next person? You'll be the first that we're starting this with, so I didn't have one for you.
A question to ask the next person.
I happen to know the next group we're a little spoiler. We're interviewing the Apollo client team on Friday. So do you have but it could be anything. Just a fun question. I'm putting you on the spot.
Okay. Here's something like how do you engage? Like, what are the key metrics that you use to measure engagement with your library? Like how popular it is? Is it GitHub stars? Is it NPM downloads? Is it activity of a particular forum or community? What is it? How do you measure that activity, and then how do you integrate feedback from the communities if people are happy or they're not happy? How do you take that temperature and react to it?
Awesome. That was such a great question. So we're off to a great start then. Thank you for, I know it's a bit tough to just spring those things on you, but those were really great ones. We'll definitely be asking those. Okay. Well, hopefully we didn't miss anything major. Did we cover
If you want to see, I did have one more thing to demo, which should be short, but I don't know that we can throw in. And to do it, we would have to go back to our main function here. And this is the one that, let's see, this is the one that started the two different servers. So what I was thinking we could do, because I think it's a great example of how to use the scope, is to make a file watcher that restarts these servers whenever something changes. So if we make a little dev script here, I'm going to kind of wave my hands a little bit. We won't go into it, how I created this stream here of these changes. But this is, suffice it to say, it's a file watcher, and we're watching the main TypeScript file. And we're going to get, this is just a subscription, which is, we can look at the this next operation here is, oops, hold on a second.
Does that mean we can for loop over the changes as well?
Yes, it does. So we can for loop over the changes, although we won't be doing that in this particular example. We're going to be using a while loop, but you can see it's an iterator result. So this is the equivalent of a async iterator, which is an async iterator. The next returns a promise of an iterator result. This returns an operation that returns an iterator result. So what we're going to do is we're just going to make an infinite loop while true. We're going to create a command here, and the command is a resource. And we're going to do basically our same way that we were running our command, our main.ts. And so this is going to create a resource. And then what we're going to do is we're just going to wait until we get the next change. And then when we get that change, what we're going to do is we're going to wrap all this in an action.
Okay. I must be getting somewhere. I was going to ask that, and I'm very glad
Right.
Maybe I understand
So
what's going on.
and then what we're going to do is notice we have this continuation here that we got with the action. And then after we get our first change, then we're going to restart. And so what this is going to do is we're going to loop infinitely. We're going to invoke this action. We're going to create a command resource. We're going to wait for the next change, and then we're going to restart. And what happens with this restart then is we're going to kill off this command. And we saw what a resource looked like. You can see basically we're going to send the sig into it.
Yep.
But this is a command resource is a resource that provides a command or provides a process. And if we look at that, you can see it's an operation of Deno child process. And so then now if we run this, if we run our dev script, you can see it starts our servers like before, but if we go and we actually edit our main file and we want to say, let's say Galaxy here, you can see it actually tore it down and then restarted it again.
Wow. Just like that.
But we didn't, just like that. And that I think really demonstrates the power of Effection. No.
This is, I'm joking because this is something that's like destructively difficult to do at certain points in JavaScript's history. I don't know. I personally spent so much time trying to get this working. I'm very impressed. And all we did, yet again, all we did was bring in action and main, and the rest is just plain JavaScript.
Yep. It's all about composition and making. If you focus on making the composition easy, then everything else falls into place. And so that's what's really the difference. It's because every operation gets run to completion, it composes very cleanly, and you just don't have to worry about the teardown as much.
It's amazing.
Yeah, it's like not having to worry about malloc and like freeing variables. Like you don't have to worry about the teardown.
Right, and that's what a game changer I think this is. Because think about what a game changer is not having to do explicit memory management was the entire state of programming. Think about what a game changer not having to worry about memory addresses of functions and jump values and return values moving from goto based stuff to having structured programming. I think this is the next evolution.
I know we're like way over time. I've been meaning to ask you what your thoughts were on there's like the symbol.disposable thing that just happened with the explicit resource with using and the explicit resource management stuff. Do you guys have any takes on the using keyword and also resource management with the disposable thing?
I do. Eric, do you have anything to say on that? I know I've definitely got a spiel, but
you got an hour?
Oh, okay. All right. Never
mind. Charles and I have talked about it. Yeah.
Yeah.
Okay.
I think right. Personally, I think it's okay. I don't think it really. I think the problem is that a lot of the asynchronous helper stuff in JavaScript is nibbling around the edges of the problem, which is structured concurrency. And other languages like Swift and Java are going for it wholesale and wholemeal. And so I think that explicit resource management is good. I think we will probably utilize it and make it very easy to work with inside Effection because, hey, guess what? Using works inside generator functions. And I
really?
think we'll actually, and so we'll actually make it very easy to use explicit resources because essentially when you spawn a task, you have you can, if you want to, you can use it with a using statement. Although at the end of the day, I do think it is ultimately a band-aid for the fact that you cannot bind asynchronous processes to a lexical scope implicitly. So this is one of the differences in Effection is that the teardown is implicit. You don't actually have to enumerate it. And part of that is the power. You can't inadvertently not. And in fact, when you do, like this kind of got you, this caveat that Eric was talking about earlier, where if you spawn something and you don't explicitly await for the end of that computation, Effection will shut it down. that's better than the opposite, which is to not shut it down and just leak it. So because Effection doesn't leak anything, you can't, like, it's because precisely that it doesn't leak anything that you see these things going away before you expect them to. And so to say, like, unless I explicitly tell you to respect the lexical scope, you're not going to respect it, I think is a little bit inverted. The other thing about explicit resource management, which I think is something that's also very problematic about JavaScript, is there is a dichotomy between async code and sync code. And everything like async generators, async iterables, all of them kind of just serve to exacerbate this split and this schism. And explicit resource management is yet another mechanism that kind of doubles down and widens that gap. One of the things that I hope we've shown today is that there is no difference between async code and sync code in Effection. And in fact, you can tear down async resources using synchronous methods in Effection because they all boil down to just a series of synchronous functions that are stitched together over time. And so Effection and using the delimited continuations heals this rift. You don't have to think about synchronous code and asynchronous code. I mean, you still do in some cases, but it's much less. And certainly at the high level API level, there is not this jagged divide that goes between them.
Wow. Well, that's something I'm definitely going to be watching. I'm very interested to hear how this is all going to play out in the long term. And I'm glad that you guys are already on the case with using the using keyword. So in any case, thank you so much for taking the time, both of you, and for working on this. It's super cool to be at the forefront and watch these things on the bleeding edge occur. I'm cheering for you, and I'm so excited to see where this happens or where this goes in the future. Where can people reach you guys?
So you can find me I'm Cowboy D on GitHub. I'm also Cowboy D on Twitter, although I'm not very active anymore. And I think it's and I don't even know where I am on Mastodon. Also, okay. I'm pretty much Cowboy D everywhere.
Cool.
And
Eric,
I did mention you can, Cowboy D at frontside.com if you want to send me an email. But please feel free to reach out to me. I really do. I love talking about this stuff. I created this so that people could use it.
Wonderful. How about you, Eric?
My main blog and entry point is bower.sh. So you can just go there. You'll find me.
Cool. All right. And check down in the description. We always post that stuff down in the description, but it's nice when, like, as you just did, Charles, I like to ask so that people hear you say, please do reach out to me. Fan mail is nice too. I send fan mail to lots of places saying thank you for making your library. I think it's cool. But in any case, thanks so much, guys. And maybe for V4, we can meet up again next year.
Yeah.
Right? All right. We'll see you later.
Awesome. All right. Bye-bye.